Hi everybody, this is section 7.3, similar polygons for our Math to 11 geometry class. So far we've proved polygons are congruent, but we really haven't talked much about similar polygons. And similar polygons are figures or similar figures. They have the same shape, but they're not necessarily the same size. Excuse me, so the symbol that we use is the wave without the equal sign. Now, not all figures, just because they're the same shape, are similar. They do have to meet some requirements. In order for figures to be similar, they have to have corresponding angles, must be congruent, and the lengths of corresponding sides are proportional. So if you were to take the lengths of corresponding sides and look at those as a proportion, the proportions would always be true. And also if you were to simplify the fractions, if they could be, they would always simplify to the lowest value that would be the same. When we look at similar polygons, we can write a similarity statement using corresponding vertices in order. And we do that, we can make an extended proportion. So with our extended proportion here, for our figure that was on the other page, AB over GH, AB would correspond to one side on one of the figures, GH would be the corresponding side on the other figure, and so on down the line. And those, when you add in those numbers, if you were to simplify all those fractions, they would all simplify to the same thing. For instance, like 3 to 2, or 7 to 4, 2 to 1. All right, so here we are going to name pairs of congruent angles. They tell us here that triangle MNP is similar to triangle SRT. And again, when you name similar triangles, you name them just like congruent ones, you have to keep the vertices in order. So even though my two triangles are not oriented the same way, I can find out corresponding angles by using the naming of the two triangles. So for congruent angles, angle M is going to correspond to angle S. So M will be congruent to S. So we'll say angle M is congruent to angle S. Then I know that N is congruent to angle R because they're both in the same spot. So we'll say angle N is congruent to angle R. And then our last pair will be angle P and angle T. So angle P is congruent to angle T. Always angles are congruent, doesn't matter how big or how small the figures are, or the difference between the sizes. Now, extended proportio for the ratio of corresponding sides. Here we have 3 sides, so we're going to have 3 ratios. So, and again, using my numbers to kind of help us out here, if I look, I know that side MN, which is right here, is going to correspond to side SR. Again, the letter, so I can say MN is in proportion to SR. It's not equal, but it's in proportion. Then we could do next NP and RT. So I could say NP is in proportion to RT. And then finally, our last pair, we have MP and ST. So MP and ST. They are all in proportion to each other. And since we don't have numbers, that's all we can do to write the extended ratio. When we are looking at similar proportions, sometimes they'll ask for a scale factor. And if they give you numbers, your scale factor is something that I mentioned before. It is the corresponding linear measurements of the two similar figures. So like I said, your proportions, if you apply numbers to them, if your figures are similar, all of those ratios will simplify to the same fraction, and that is going to be your scale factor. So here the scale factor is 5 to 2, which is similar to saying, so for every, let's say we're dealing with inches, for every 5 inches on the large figure, the small figure is 2 inches. So that's what a scale factor is. All right, so here we are going to look at our 2 figures and determine if our figures are similar or not. Now, we're going to start off and kind of name our polygons by looking at the marked angles. So I know we have polygon, it's going to be J, and then I'm going to go to K, L, and M. So it's a quadrilateral. And the other one is, if I follow the same marking, so 2, it would be T, U, V, W. And again, I just followed the angle markings around to help me name them, because that kind of helps you look to see if they're similar or not. So let's look at our first. We can see that all corresponding angles are congruent, so it meets that requirement. But what about side lengths? So let's look. Our first side length I'm going to look at is JK over TU. So it's this top part here. And that length of the measurements, if I look at it as numbers, would be 12 over 6, which simplifies to 2 over 1. Now, if I continue around here, if I look at KL and UV, so if we did KL over UV, that is going to give me 24 over 16 if I put the measurements in there. And if I simplify those, I can simplify them both by 8. So if I divide them both by 8, I end up with 3 over 2. So I'm going to stop right there, because these 2 ratios did not simplify to the same thing. One is 2 over 1 and the other is 3 over 2. These figures, even though the angles are congruent in the 2 figures, the sides are not in proportion. They don't have the same scale factor, so they are not similar figures. So we can say they are not similar figures. All right, let's look at the next one here. So again, I'm going to kind of use my angles to give me the letters to put them in like the same order, so it can help me find my corresponding sides, because sometimes that's hard if the figures aren't oriented the same way. So I'm going to start, we'll start at the 1 mark, so that's going to be C, and then I'll work my way around. So we have triangle CAB, put my triangle there, and then we also have triangle, if I start at 1 and go to 2, it's going to be FDE. All right, now let's see here. Angles, we can see we have 3 pairs of congruent angles, so that's good. Now let's look at side measures. So I'm going to start with CA and FD. So the length of CA was 8, and the length of FD is 10. So when I simplify that, I would get 4/5. Next, let's look at, we'll do the next one, we'll do AB and DE. So AB and DE. AB is 12, DE is 15. Let's see here, I can simplify both of those by 3, and when I do that, I do get 4/5, so that is good. So we have 2 pairs of corresponding sides that simplify to the scale factor of 4 to 5 right now. So let's look at the third side. We have CB over FE, and CB is 16, FE is 20, and when I simplify that, I can divide them both by 4, and I'll end up with 4/5. So notice how each ratio of corresponding sides simplified to 4/5. So that means that these 2 triangles are similar to each other because corresponding angles are congruent, and we know that through the markings, and then corresponding sides are also similar in the same proportion and the scale factor of 4 to 5. So my scale factor is 4 to 5, and the similarity statement would just be triangle CAB is similar to triangle FDE. And again, you want to keep the order the same, but they are similar figures. All right, so here they told us that quadrilateral ABCD is similar to EFGD. So we know they're similar, so we know that the sides are in proportion to each other. We want to know the value of x. So to do this, we're going to set up a proportion. And what you want to do is, when you write your proportion, you want to find a pair of sides where you know both measures. So here, I know the measurement right now of ED and AD, because I know AD is right here, ED is right there. I know that ED is 6 and AD is 9. And then what we're going to do is, the side we don't know, FG, is our x, and FG comes from the smaller figure. So because it's the smaller figure, it's going to go with the 6. And then it corresponds to BC, so that'll be 7.5. And now all we have to do from there is solve our proportion. So when we cross multiply, we get 9x equals, and then 6 times 7.5 is 45. Divide by 9, so x is going to be 5. So if we look right there, that is the value of x. So it's just setting up a proportion, making sure you have corresponding sides put together, and then solving the proportion for x or y or whatever variable you're given. And that is it for 7.3.